Hi everyone, welcome to this lecture. So in this lecture, we are going to solve numerical example on Gini index. We know that the Gini index will be used to calculate the information gain, and information gain is very important term in order to construct the decision tree. So this is a data set which I am going to use in this numerical example. Now you are familiar with this data set because we have already used this data set in the numerical example of the entropy. Let's understand this data set again. So in the data set, we have 6 columns: patient ID, emotional state, liver condition, heart size, blood pressure, and diabetic. Okay, the first column is about the patient ID. And the last column are our label of the dataset, where no represents that the patient is not a diabetic patient, and yes indicates that the patient is a diabetic patient. Now the middle 4 columns are our features. So basically we have to use all these 4 features in order to classify the patients into no and yes. Okay, so the first feature is emotional state, liver condition is the second feature, then heart size, and then blood pressure. So basically we have to find the Gini impurity of each of the feature of this data set, and then from the Gini impurity I will calculate the information gain. And we know that highest the information gain of the feature, most important the feature will be, and that feature will be used as a root node in order to construct our tree. So let's start with the first feature, which is emotional state. So this is my first feature of the dataset, emotional state. Keep in mind, this is the equation of a Gini index. In that equation, there is a square on the probability. So basically, first we calculate the probabilities with respect to all the classes. That is, for I is equals to 1 to C. So here in this dataset, we have only 2 classes, that is yes and no. Then we square the probabilities, and finally we subtract all these values from the 1. So here, the first step is that I am going to calculate the Gini index of the whole data set. Remember the formula of information gain for a Gini index. The information gain will be the difference of the Gini index of the parent subtracted the weighted Gini index of each of the children. So in that case, the Gini impurity or a Gini index of the whole data set will be act as a Gini index of the parent. And the Gini index of the children will be the Gini index of each of the values inside the emotional state, that is sad, calm, and stress. Okay, how to find the Gini index of the whole data set? So in whole data set, we have 14 samples, out of which 9 belongs to class yes and 5 belongs to class no. So this is the probability of yes. This is the probability of no. According to the equation, I have to square them and subtract it from 1. So I will get this value. So this is the Gini impurity of the whole data set. Now it's time to find the Gini impurity of all the values present in the emotional state. So we start with sad. If we see sad appears 5 times, 1, 2, 3, 4, and 5. Out of these 5 time, it appears 2 times with yes. So if we see here, it appears with yes, and here with yes, and 3 times it appears with the label no. So this is the probability of sad with label yes, and this is the probability with label no. Square the probabilities and subtract it from 1 in order to use this equation. So this is the Gini index of sad. So next step is to find the Gini index of a calm. So calm in this column of our emotional state appears 4 times and all time with the label yes. So it has the probability of 1 with label yes and 0 with the label no. So if I use the Gini index equation, I will get 0. Similarly, the Gini value for the stress is 1 minus 3 by 5. So stress has also appeared 5 times in the column of emotional state. Okay, 3 times with the label yes, 2 times with the label no. So these are the probabilities. So final step is to subtract the probabilities from the 1 and we will get these values. So in this way, we have calculated the Gini index of all the values which are present in the emotional state. Now it's time to find the weighted Gini index. So here we will find the weighted Gini index, that will be called the Gini index of the children node, and then we have to subtract it from the Gini index of the parent node, which we have already calculated. Okay, now how to find the weighted value for the Gini of each of the sad, calm, and stress? Since sad appears 5 times out of 14, so its weight is 5 by 14. calm appears 4 times, so its weight is 4 by 14. Stress appears 5 times, its weight is 5 by 14. So these are the weights associated with sad, calm, and stress. These are the Gini values, that is 0.480 and 0.48. And this is our Gini of the whole data set. So if we solve all these values, we will get 0.116, which is the information gain of the whole feature, that is the emotional state. Now it's time to start the second feature, which is the liver condition. Now liver condition also has 3 values: fatty, normal, and shrink. Okay, so if we see fatty appears 4 times, 1, 2, 3, and 4. Out of these 4 times, it appears 2 with the label yes and 2 with the label no. So if we put the values here, square the probabilities and subtract it from 1, we will get 0.5. And we know that 0.5 is the highest value of the Gini index. The highest value of the entropy was 1, but for Gini index, we have the highest value of 0.5. So 0.5 only appears when we have samples equally divided between the classes. So we can see that we have 4 samples for fatty and they are equally divided between yes and no. Okay, then it's time for a normal. Normal appears 6 times, 4 with one label and 2 with the other label, that is yes or no. So this is the same equation which I have now used so many times. So subtract these probabilities, square from the 1, we will get 0.439, which is the Gini impurity of the normal. Now it's time to find the shrink, that is the Gini index of a value shrink. So shrink appear 4 times, 3 with the yes and 1 with the no. So if I use this equation, I will get the value 0.375. So in this way, we have calculated the Gini index of all the values present in the column of liver condition. Now it's time to find the weights of these values so that we can calculate the weighted Gini index. So here is the time to calculate the weighted Gini index. The weight of fatty is 4 because it appears 4 times out of the 14 entries. Normal appear 6 times and shrink appear 4 times. So these are the weight of all these values and these are their Gini impurity or Gini index value. Subtract these values from the Gini index of the dataset. So we will get 0.022 as a information gain of a liver condition. Now it's time to move to our third feature, which is heart size. Now heart size has only 2 values, large and regular. Okay, so large appear 7 times, 3 times with one label and 4 times with the other label. So this is the Gini value of the large. Regular also appears 7 times, 6 with the one label and 1 with the other label. So this is the Gini index of a regular, which is 0.245. After finding the Gini values, the next step is to find the weights of each of these Gini values. So the weights here are equal because both appear 7 times. So the weight of large is 7 by 14. Similarly, the weight of regular is also 7 by 14. So we will multiply the weights with their respective Gini index value. And then finally, we subtract it from the Gini index of the dataset or the Gini index of a parent node. And this is our final information gain of a heart size. Now the next step is again to find the information gain of our last feature, that is blood pressure. So blood pressure has 2 values, high and low. So high appear 6 times, 3 with the label 1 and 3 with the other label. So if I solve this equation, I will get the value of Gini index as a 0.5 for this high value. Now for low appears 8 times. So in this column, low appear 8 times and 6 times with one of the 2 label and 2 times with the other label. So if we subtract these values from the 1, that is the square of the probabilities, then we get 0.375. After calculating the Gini index of all these high and low values, now it's time to find their weights. So high appears 6 times. So its weight will be 6 by 14. Low appears 8 times. Its weight will be 8 by 14. Now we will multiply these weights with the Gini values and then subtract it from the Gini value of the dataset. We will get the information gain of blood pressure, which is a very small value here, only 0.03. Now the information gain of all the 4 features have been calculated. We can see that the gain of the emotional state is high. Therefore, it is our root node and our split start from this feature. So here we are in our split one. So this is our split one. We started from the emotional state. Emotional state has 3 values: sad, calm, and stress. Sad has 5 entries. 2 belongs to yes, 3 belongs to no. Calm has 4 entries, all belongs to yes. So in this branch, the classification has been finalized. So we do not need to split it further. For stress, we have 5 samples, 3 belongs to yes and 2 belongs to no. So we have to split this branch further because the classification is not finalized, and we have to split this branch further. Okay, we will start with sad. So our split 2 will start with the calculation of a sad. Okay, this is our calculation for the second split, and second split, the sad will be act as a whole data set. So the first step is to find the Gini of the whole data set, which is sad in this case. So sad has only 5 entry. So this is the reduced form of the data set for our second split. And these are the corresponding value of the liver condition, heart size, and blood pressure when we have only sad in our emotional state, and these are the labels. So if we see, sad appears 2 times with yes and 3 times with no. So out of 5 entries, 2 times with yes and 3 times with no, so its Gini value will be 0.48. Now find the Gini value of a liver condition, heart size, and blood pressure. So for liver condition, we have total 5 entries, and we can see that we have values fatty, normal, and shrink. So fatty appears 2 times, normal appears 2 times, and shrink appear 1 time. Okay, so fatty appears 2 times, all with the labels no. Therefore, its Gini value is 0 because the classification has been done. If we see here shrink as well, shrink appear only 1 time with label yes. So here its Gini value is also 0. If we see normal, normal appears 2 times, 1 with no and 1 with yes. So its Gini value is 0.5. Now it's time to find the weighted Gini values. So the weight of fatty is 2/5. Weight of normal is 2/5 because it appears 2 times, and the weight of shrink is 1/5. So these are the weights, and these are their corresponding Gini values. So solve this value and subtract it from the Gini of the dataset, which is sad in that case. We will get the information gain of liver condition as 0.28. Similar way, we will go for a heart size. For heart size, the 2 values are large and regular, and their Gini values are 0 because the large appear with the no. If we see here, the large appear only with the no and regular appear only with the yes. So they are classified. So their Gini values are 0. Since their Gini values are 0, so 0 will be multiplied by their weights, and we will get 0 here. If we subtract 0 from 0.48, we will get the information gain of heart size is equals to 0.48. Now move on to next feature, which is low in this case. If we see low, blood pressure in this case. So blood pressure has 2 entries, high and low. So if we count high, high has 2 entries, 1 with no and 1 with yes. On the other hand, low has 3 entries, 1 with yes and 2 with no. So these are their respective Gini values. So this is the Gini value of a high. It appears 1 time with yes and 1 time with no. This is the Gini value of low. It appears 1 time with the label yes and 2 times with the label no. Now, after finding the Gini value, it's time to find the weights and find the weighted Gini values. So the weight associated with high is 2/5 because it appears 2 times out of the 5 samples, and low appears 3 times, so its weight is 3/5. These are their respective Gini values. Subtract them from 0.48, we will get 0.01. Now for split 2, our calculations have been completed, and we can see that the gain of heart size is high. It is 0.48. Therefore, it is a node for our second split. Here is our second split. Our second split will start from the heart size. It has two values, large and regular. Large has 3 samples, all belongs to class no. Regular has 2 samples, all belongs to class yes. So we do not need to split these branches further because the classification has been finalized. Now only this branch is left and we have to split it further with the help of the value stress. Now here we have transformed our original data for stress. So here stress is considered as a data set. These are the corresponding value with the liver condition. These are the corresponding value with the heart size. And these are the corresponding value with the blood pressure. So here stress will be used as a whole data. So first we will find the Gini value of the stress. So stress appear 3 times with the label yes and 2 times with the label no. So these are the probabilities. Square them and subtract it from 1. We will get 0.48. Now it's time to find the Gini values of the liver condition. Now, student, I leave it for you. This is our third split. You have clearly understood the split 1 calculation and split 2 calculation. Now, it will be a good practice for you if you calculate by yourself about the calculation of a split 3. So these are the calculation of the liver condition. This is the final value of the information gain of the liver condition. The next feature is a heart size. Similarly, you will calculate the Gini values of all the entries of a heart size that is large and regular. After calculating their values, you will find the weights. And after calculating the weights, you will multiply those weights with the Gini values and finally subtract it from the Gini of the dataset. So this is the information gain of a heart size. The final step is to find the Gini values for a blood pressure feature. It has 2 values, high and low. So the Gini value of both are 0. Why both are 0? Because if we see high, it is classified. It appears 2 times, both time with the label no. If we see low, it appears 3 times and every time with the label yes. So their classification has been finalized. Therefore, their Gini values are 0. So if the Gini values are 0, so their weighted values are also 0. So if you subtract it from the whole dataset value, you will get 0.48. So these are the information gain for our third split for the feature liver condition, heart size, and blood pressure. We see that the gain of blood pressure is high, so it will be our next node for the split. So blood pressure is high here, that is the information gain is high. So we are using a blood pressure as our next root node just for this split. So it has 2 values, high and low. So inside high, it has 2 samples, all belongs to class no. And inside low, it has 3 samples, all belongs to class yes. So we can see that this tree has been completed. All the classification has been finalized. There is no need for further split. So in this lecture, you learn how to use Gini impurity in order to find the information gain and then in order to construct the tree. So Gini impurity is a second important criteria in order to find the information gain after the entropy. So we can see that the tree is exactly the same which we obtained in the numerical example of the entropy. So during the construction of a decision tree, you can use any criteria in order to calculate the information gain. That is, you can use entropy and you can also use Gini impurity. So I hope you understood this lecture very well. Thanks for listening and I will see you in the next lecture.